Hi students, today we are going to see the session 6 homogeneous partial differential equation. An equation of the form a into dou square z by dou x square plus b into dou square z by dou y dou x plus c into dou square z by dou y square is equal to f of x comma y. This is called the homogeneous second order partial differential equation. This can be written as a into d square plus b into d dash plus c into d dash square into z is equal to capital F of x comma y, where d is equal to dou by dou x and d dash is equal to dou by dou y. So previously we saw the ordinary differential equation. So there we have only the d and constant term. Here we have a d dash is having, that is here the partial differential equation we have the more than one independent variable is having. So therefore we have d and d dash is having. So the same procedure what we did in the ordinary differential equation. So the same way here we are going to use. The homogeneous partial differential equation means all the order is same. Here also order 2, here is also order 2, here is also order 2. So if all the orders are same, therefore the given differential equation is a homogeneous differential equation. So for solving this homogeneous differential equation, we have a two parts. One is a complementary function, another one is a particular integral. Next we are going to look in the problem. Find complementary function and particular integral for the partial differential equation d cube minus 7 dd dash square minus 6 d dash cube into z is equal to x square y plus sine of x plus 2y. So consider this as a given equation. Now we are going to write the auxiliary equation. So in ordinary differential equation, we just replace d by m. But here in the homogeneous PDE, we just replace capital D by m and capital D dash by 1. So we get the auxiliary equation as m cube minus 7m minus 6 equal to 0. So now we are going to solve this equation. So you will get the three values for m because here the highest degree is 3 having. So first we have to use by trial and error method. If you put m is equal to 1, you should not get the values, the equation not equal to 0. If you put m is equal to minus 1, so minus 1 the whole cube is minus 1. Here minus 7 into minus 1 get the plus 7, then minus 6. So minus 7 plus 7 equal to 0. Therefore m is equal to minus 1 is a root. So another two roots we are going to calculate by using the synthetic division method. So coefficient of m cube is 1. The coefficient of m square is not having. So in that place put 0. Then coefficient of m is minus 7. Then the constant value is minus 6. So here if you substitute m is equal to minus 1, then the equation satisfies. So therefore you consider that value minus 1. So here first value always put the 0. So add these two, 1 plus 0 you get the 1. Now these two have to multiply. 1 into minus 1 minus 1. 0 plus minus 1 minus 1. Minus 1 into minus 1 plus 1. Minus 7 plus 1 minus 6. Then minus 6 into minus 1 plus 6. So minus 6 plus 6 0. So now we have to write this as a quadratic equation m square minus m minus 6 equal to 0. So solving this quadratic equation we get the m is equal to 2 comma 3. Then now we are going to write the complementary function. So complementary function is equal to f1 of y minus x plus f2 of y plus 2x then plus f3 of y plus 3x. So now we are going to find the particular integral. So there in a given question we have a two particular integral is having. So this one you consider as particular integral 1. This one I consider as a particular integral 2. So now we are going to find the particular integral for first one. D cube minus 7 d dash square minus 6 d dash cube into x square by. So here I have to take out the d cube outside. So this can be written as 1 minus 7 d dash square by d square minus 6 d dash cube by d cube. So from both the term minus is common. So take out the minus outside. So minus of 7 d dash square by d square plus 6 d dash cube by d cube of x square by. So this 1 minus x form is having, if this term take it to the numerator, so can be written as whole power minus 1. So this is of the binomial expansion 1 minus x whole power minus 1. We know the formula for binomial expansion 1 minus x whole power minus 1 equal to 1 plus x square plus x cube plus etc. So now after expanding this as a binomial expansion, so first one 1 into x square y is x square y Then d dash is nothing but differentiation with respect to y. So first time if you differentiate, you will get the 1. Second time if you differentiate, it become a 0. Then the third time is also differentiation of y is 0. So therefore, in this place, the first this term is also 0, this term is also 0. So only you get the x square y. So now we have to integrate this one thrice. That is the first time integrate, you will get the x cube y by 3. Again integrate, you get the x power 4 by 12. Again integrate, you will get the x power 5 by y. X power 5 y by 60. So this is the PI1. Next we are going to find the PI2. So 1 by d cube minus 7 dd dash square minus 6 d dash cube into sine of x plus 2y. So we already see that ordinary differential equation. There sine, either if you have a sine or cos, replace d square by minus 1. Here the partial differential equation, we have to replace d square by minus 1 and d dash square by minus 4 and d dash by minus 2. So after this one, so here d cube can be written as d square into d. So instead of d square, we replace minus 1. So remaining will get the minus d. Then here d dash square can be written as d dash into d dash. D dash we have to replace as minus 2. So minus 7 into minus 2 into d dash plus here also we have to replace d dash square by minus 4. Minus 4 into d dash will get. So already minus is having. So plus 24 d dash into sine of x plus 2y. Then after simplifying, we get minus d plus 14 d dash plus 24 d dash. So add these two, will get the 38 d dash. So after this one, we have to take the conjugate of this one. So what is the conjugate of this one? So minus d minus 38 d dash. So multiply the conjugate by numerator and denominator. So in the denominator, we got the result as d square minus 1444 d dash square into sine of x plus 2y. So again have to use the same procedure. Replace d square by minus 1, d dash square by minus 4. So after replacing, we get the result as 5775 in the denominator. So numerator d of sine is, that is differentiation of sine. So differentiation of sine is cos. Cos of x plus 2y into, with respect to x, we have to write as x is 1. Next one, d dash is nothing but differentiation with respect to y. So differentiation with respect to y. So cos of x plus 2y into 2. So both you have to add, then we'll get the minus 77 by 5775 into cos of x plus 2y. So finally we have to write the solution as Z is equal to complementary function